This is a video about AC and DC, alternating current and direct current. So AC is alternating current, and DC is direct current. To explain the difference between the two, I think I'm going to use a light bulb. So this light bulb has two electrical connections. One wire hooks on the bottom here and one wire hooks on the side. Whether you're talking about old school incandescent light bulbs like this one on the screen, or LED bulbs, or computers or dishwashers, they're going to have two wires coming in and out. So this example works as well as any. So current, if we're thinking about current, we're thinking about electrons in this conductor, in this wire. So if we could see down at the atomic level, we would see that the wire is full of these little electrons all over the place. And if we want the light bulb to light up, then what we need to do is we need to move them with a sufficient amount of energy. So we've got two choices. One choice is to take the electrons and move them in one direction only, and then the other choice is to take the electrons and give them a little nudge this way and then give them a little nudge that way. Either way, it doesn't matter. You can heat up the filament enough to get the light to be produced. So that's, in essence, that's the difference between AC and DC. The first way that I described, DC, it's all in one direction. And AC, the little nudge in one direction, then the nudge in the other direction, that is two directions. So it's going back and forth. So there's my description of what current is. So what's the problem, or why is there a problem? The problem arises when you've got a factory some distance away making electricity, producing electricity, and you live however far away, and you want to watch TV or do your laundry or whatever. You need to have conductors going to your house, and the problem is that if you try and use DC, what you're trying to do is you're trying to make the factory push those electrons all the way through whatever distance of wires through the devices in your house while you use them, and then push them all the way back to the factory. And it turns out that you need such high voltage, so much push, that's what voltage is. You need so much push that what you might wind up doing is melting the wires, you might wind up burning down your house. It's just not the best way to go. If you want to send electricity through a greater distance, let's say here's our factory, here's our house again, trying to draw quickly. What if instead of pushing it the whole way, what if you gave the electricity a little nudge this way and then a little nudge that way, and just kept doing that over and over again? This is called alternating current. So just really quickly here, let me show you a graph of the two. Direct current provides a constant push in one direction. And this is what you might get from a battery, or what you would get from a battery. Alternating current, so this one is DC, alternating current, it changes from a negative maximum to a positive maximum, negative, positive, and so on and so forth. It does it many times per second. Actually, in our country, in the US, it switches directions 60 times per second. So this way of moving electricity, the little nudge and the little push, AC, this turns out to be the best way to move electricity over any distance. Now, on your own time, if you want to, you should Google Edison versus Tesla, and you'll find out about a very heated, nasty battle between these two guys. And some of the things that this guy did, some of the things he did were actually kind of nasty. Actually super duper nasty, in my opinion. So I encourage you to look that up sometime on your own. So now I want to talk about my devices. Like, let's say I have a fan, just a regular old fan that I plug into an outlet. That fan needs AC. But now I want to talk about my computer, or maybe my cell phone, which is a computer. So let's just try to write phone here. These guys, they have delicate components that were designed to use DC. So if the factory sends us AC, something like a fan is going to be totally happy. It's going to be like, yep, plug me in, I'm going to work, I'm going to move air all over the place. But something like a cell phone, which is filled up with computer chips, is going to be destroyed. So what we've got to do is we've got to take AC and we've got to turn it into DC. So how do we do that? Well, there is a device called a rectifier. And this is the schematic of it, and for this video it doesn't matter if you know what that is, but I'll tell you that it takes in AC, which is always positive and negative, and it gives off a constant DC. And it basically what it does is it turns alternating current into direct current. What do rectifiers look like? This device, what does it look like in reality? Here's one from a motorcycle. Inside of a motorcycle, the engine spins around. There's a thing called a stator, and it makes alternating current. This device right here takes that alternating current, which has this inside, this bridge rectifier, and it turns it into direct current. So that's what a lot of our devices inside of our homes need. So if I want to charge up my phone, what's coming out of the wall is alternating current. I use some sort of a device to turn it into direct current, and then all of my circuitry is safe.